Hi, my name is Arturo Gutierrez. I'm going to do the video for problem 13 on exam 3, module 5 and 6 test. So for 13, part A, we're basically given most of the information. We have the emission, we have the effective stack height, the wind speed, the distance. We're also given that it's a Class B condition, which we can refer to the table and get a p-value of 0.15. And then using the p-value or using the Class B condition with a distance of 2 kilometers, we can get our sigma y and our sigma z from the tables. Also tables in the textbook. So the only thing we're missing is the velocity at the stack height, which is UH. So using equation 7.46, you could rearrange it and set it to velocity of the stack height, and then you just go ahead and plug in the numbers from there. I got a velocity at the stack height of 7.06 meters per second. Then after that, you have all the information you need to use equation 7.49 to find the concentration at ground level. So you plug all those numbers in. You plug in the emission, you plug in the velocity at the stack height, sigma y, sigma z. Once calculating all that, I got a concentration at 2 kilometers in the x direction, 0 in the y direction because it's at ground level, 0.5197 micrograms per meter cubed. So that's how I solved for the concentration 2 kilometers away downwind. So then for part B, it's basically asking us to use that concentration. So it's basically, the way I understood it is basically there's a house 2 kilometers downwind, and since the concentration outside of the ambient air is going to be the concentration that we solved for, 0.5197, we basically, that's the ambient air concentration that I used in part B, which was solved for in part A. And then at that point, all the other information is given. We can use equation 7.64, and a lot of this stuff cancels out. So since it's a conservative pollutant, our K value is 0. It says in the question that there's no source inside the house, so there's no source strength. So source strength is also 0. So basically having a source strength of 0 and a K value of 0, most of that governing equation gets canceled out. So you're left with concentration at time t equals the concentration of the ambient air, 1 minus E negative N times T. So basically you plug in T of 2 hours. After plugging in 2 hours into the equation, that's how I came up with a concentration after 2 hours of 0.204 micrograms per meter cubed. Thank you.